This is a video from the Exam 3 review in linear algebra. Let's take a look at problem 2. Find bases for the eigenspaces of A, which is the matrix 6, 3, negative 8, 0, negative 2, 0, 1, 0, negative 3. Now, lambda I minus A is equal to the matrix lambda 0, 0, 0, lambda 0, 0, 0, lambda minus the matrix 6, 3, negative 8, 0, negative 2, 0, 1, 0, negative 3. And this is equal to the matrix lambda minus 6, negative 3, 8, 0, lambda plus 2, 0, negative 1, 0, lambda plus 3. Now, we're going to set the determinant of lambda minus A equal to 0 and solve for lambda. So this will give me the eigenvalues of A. So lambda plus 2 times the determinant of lambda minus 6, 8, negative 1, lambda plus 3 equals 0. So lambda plus 2 times the quantity lambda minus 6 times lambda plus 3 minus a negative 8 equals 0. So lambda plus 2 times lambda squared minus 3 lambda minus 10 equals 0. So lambda plus 2 times lambda minus 5 times lambda plus 2 equals 0. Solving for lambda, we get lambda equal negative 2 twice, or lambda equal 5. So those are my eigenvalues of A. From here, let's take lambda equal 5. Now let's go back. So I'm going to replace lambda with 5 in this matrix here. So notice how my first row will be negative 1, negative 3, 8. My second row will be 0, 7, 0. And my third row will be negative 1, 0, 8. And that's what happened. I get negative 1, negative 3, 8, 0, 7, 0, negative 1, 0, 8. And I'm going to take that matrix and multiply by the column vector ABC, and I'm going to set it equal to the column vector 0, 0, 0. And that's going to produce a system of equations. And so I get negative A minus 3B plus 8C equals 0. 7B equals 0, and negative A plus 8C equals 0. Solving for A, I get A equals 8C, right? And then if I take the second equation and solve for B, I get B equals 0. Now, the column vector ABC is equal to the column vector 8C, 0C. And if I factor out the C, I get C times the column vector 8, 0, 1. A basis for the eigenspace of A is the column vector. It's the set containing the column vector 8, 0, 1. Now, what about for lambda equal negative 2? So, okay, let's go back again. So now I'm going to replace lambda with negative 2. Notice how the second row is entirely 0. The third row is negative 1, 0, 1. And then the first row is negative 8, negative 3, 8. So I'm going to take negative 8, negative 3, 8, 0, 0, 0, negative 1, 0, 1. And I'm going to take that matrix and multiply by the column vector A1, A2, A3. And I'm going to set it equal to the column vector 0, 0, 0. And let's see what our relationship gives. So we get negative A1 times 8, right? So negative 8A1 minus 3A2 plus 8A3 equals 0. negative A1 plus A3 equals 0. And so what that tells me is A1 equals A3 right here. So if I replace A1 with A3, that's going to force A2 into being 0. And so the column vector A1, A2, A3 is equal to the column vector A1, 0, A1. And if I pull out the A1, I get A1 times the column vector 1, 0, 1. So a basis for the eigenspace of A is going to be the set containing the column vector 1, 0, 1. Now, if you look at this basis, and then we come back and look at this basis, are they linearly independent? Right? And I would say the answer is those vectors are linearly independent. But anyway, that's how you do problem 2 from the exam theory review. Okay, thank you.